So now you know where the proof of the nth term came from. I'm going to show you how you can apply it in questions and how you should write it down to get full method marks. So let's have a look at question 1. We've been asked to find the nth term of the arithmetic sequence, and we've been given the first few terms in the sequence. I would always start by writing down A and writing down D. Now D, you can see that each time we're adding 2 to get to the next term. So in this case, the term-to-term rule would be add 2. So don't mix up the term-to-term rule with the nth term. The nth term would allow you to go directly to any term in the sequence. It didn't matter how big the number was. Whereas the term-to-term rule tells you if you've got one term, how to get to the very next term, the one directly after it. So in this case, D is 2. Now, to find the nth term, what I want you to do is write down the formula that we looked at or proved previously. And then I want you to substitute in for A and for D. Then you should multiply out the bracket and add together your like terms. And it's as simple as that. You're done. Let's try this with another example. So you write down A is -1. In this case, D is -4. Each time we're subtracting 4. UN is A plus D and -1. UN is -1. D is now a negative number. You add together like terms. -1 plus 4 is +3. So that's the nth term. With that number, I could substitute any value of n I wanted and get the next term in the sequence. You can try it quickly to see if it works here. We know, for example, U3 is -9. So if I put in here 3, that would give me -12 plus 3, which would be the third term is -9, which it was. In question 3, we've got fractions. So I write down A, which is the first term, 3. D is +1/2. Oh, sorry, D is -1/2 because we're going down. I write down my formula. Add it all together, so I'll have 3/1/2, which will be 3.5 minus 1n/2. I would probably go for a common denominator then, so I'd write 3.5 is 7/2 minus 1n/2, and I've got a common denominator of 7 minus n divided by 2. In question 4, we're going to have everything in terms of x. So A would be 3x. D would be 1x because you need to add x every time to get the next term. I'm going to write down my formula. I'm going to substitute into my formula with the x's, so 3x plus x times n minus 1. Multiply out the bracket. And again, add together the like terms. 3x take away x will be 2x plus x times m. It's done. The last question is a little bit tricky, and it's going to require that you have some knowledge of logs. What I'm going to require is that you know that in logs you can bring the power down in front. If you need to revise logs, go back. We have a whole playlist and a whole online course all about logs. Now in this situation, you can see you'd have to add log x to log x to get 2 log x. And you would have to add log x to 2 log x to get 3 log x. So in this case, our A would be log x. but d would also be log x. So now you'd write your formula down. You'd substitute an a for log x. D is also log x times by n minus 1. Here it might be easier to factor out log x from the equation. If you factor that out, that would leave you 1 plus n minus 1. 1 minus 1 would be nothing, so you'd have log x times by n, which could be written as either n log x, or you could put the n back up as a power, which would be log x to the n, which both would make sense because, for example, if n was 1, you'd get x power 1. If n was 2, you'd get x power 2. If n was 3, you'd get x power 3, and so on. So in key skill 3, we're going to be using the formulas you find to generate actual terms in the sequence. So you'll have your nth term, and you'll be looking at how to find the 8th term or the 5th term using a formula. So I'll see you in the next one. Bye for now.